Everyone could take their seats, please. Come on in from the break. We got a fantastic second panel. My name's Simon Johnson. I'm co-director of the initiative, but my only role right now is to introduce the chair of the session, who is David Autor, also co-director. David, over to you.
That's it?
That's it.
Okay. Okay. Great. Thank you all for coming. Thanks again to the Sloan Foundation. Thank you to the Hewlett Foundation, to the Stone Foundation for supporting our work. Thanks you to Julia Regier and Catherine Moffat for organizing us. So here we're going to talk, the purpose of this panel is to talk about technology and opportunity. And I think it's really important to say that we're in a remarkable technological moment for two reasons. One is, of course, we're at the cusp of an amazing set of technologies. We all have been dazzled. The other is that the amount of public dread accompanying this introduction of technology is unlike anything I imagine we've seen in history outside of the bomb. And so it's really unusual. And I think actually if you look at the polling data, you'll see that the dread is much, much higher in industrialized countries than it is around the developing world. And in fact, the uptake of AI is also lower in the rich world than it is in the developing world. And so, I don't know what to make from that, except that it is unusual that, we are, at the forefront of the technology and yet most fearful of it, using it less, and spending a lot of time worrying about its consequences. So, and I think when, of course, I think most of the time what most people are worrying about is worrying about their jobs. And the views are, I think, are very, either there will, you can think of it as the debate between Elon Musk and Jeff Hinton. Elon Musk says there will come a time soon when no worker is needed. And Jeff Hinton says, everyone should become a plumber. So there's kind of, these are polar views. Either there'll be no work or everyone will be a plumber. But that's a lot of work. And maybe we're wondering if there's anything in between that. And in particular, what is the role for human labor? What is the role for human expertise, not just the amount of work? And more fundamentally, how do we design for that, or how do we think about that? And so that's the purpose of this panel. So I have three speakers here. Sendhil Mullainathan, my colleague at MIT, someone I've actually known since graduate school, a brilliant thinker on technology and cognition and how people make decisions and how that interacts with, particularly in his recent research, with the input that machines give us. And Sendhil has given a lot of thought to the design of how people and machines can work together. So we're going to ask him to speak on that. John Horton, my colleague from the MIT Sloan School, who has done some of the most original and the most informative work on kind of online labor markets, job search and matching, and how these things go together. And so John will speak to us about the role of technology in matching workers and jobs. And then Lindsey Raymond, who is a recent MIT PhD student from the Sloan School, now at Microsoft Research, a student of Sendhil's, among others, someone I am proud to have had in my class, though not have advised. That was my mistake. And she has done, the author of 3 great recent studies on AI in the labor market, in call center operations, in hiring, and then actually in the real estate market and how people make choices. So she has a lot of very granular insight about how these things can work together and in interesting, constructive ways where you can see the upsides and the downsides and the potential. So with that said, I'm going to turn it over to Sendhil, and then to John, and then to Lindsey, and then we'll have a free-flowing conversation from there. Take it away, Sendhil.
Thank you, David. I'll just dive right in. I want to talk today about people and algorithms. As David said, if you're sitting in 2025, I had this at 2024, and at the last minute I changed the slides. None of you can see my slides, but that's okay.
Can you activate his slides?
I have to hit presentation mode. It's user error as always. There we go.
There we go.
When you're sitting in 2025, you see these algorithms, and there's a lot of questions you might have. What's the future of work? What's the future of society? We're often in the sort of fortune-telling business. And in this fortune-telling business, I want to do something quite different. Rather than looking forward, I'd like to look backwards in time. I want to look back to 1973 In fact, to March of 1973, a month before I was born, Scientific American had a very interesting article. And in this article, they were studying and documenting animal locomotion, how different animals would move and how efficiently they moved. How many kilocalories per kilometer, per kilogram, do all these animals move out? It's kind of an interesting figure. And they made a little infographic. Here's the infographic. And what jumps out at this is that mice are very inefficient. They require a lot of kilocalories. Salmon, extremely efficient. People, somewhere in the middle. Or as people were known in 1973, men. What made this figure particularly interesting was that it has an outlier data point. This outlier is what drew a lot of attention as time marched on. It was this point down here. The most efficient point by far was man on a bicycle. Why am I telling you this? I'm just running out the clock. I'm sick. I don't even know what I'm talking about. I didn't realize this was a conference on technology. I just thought we were telling stories from the past. No, because this figure is actually gone down in the folklore of computing because a famous technologist once looked at this figure and said, this is what computing should be. Computing should be bicycles for the mind. And that's a very evocative view of computing. It's a view that emphasizes them as tools that let us expand our capacities. What's interesting is we now have two very different views of computing. If you look at 2025, the bicycles for the mind view looks awfully sort of quaint and of yesteryear. Today, the view is algorithms that'll do everything a person can, and more. So what I want to do is to ask the question, how did we end up here? If for a long time, not just in 1973, roll forward to 1990, roll forward to 2000, bicycles for the mind was a pretty dominant perspective. Why did we end up here? One perspective for why we ended up here is there's something intrinsic to machine learning, to the nature of the tools, to supervised learning or deep learning, or that inherently pushes us towards this. I want to tell you, I don't think that's why we ended up here. And to do that, I'm going to illustrate it with three examples: computer vision, large language models, and audio signal processing. And the reason in each of these three cases, the most important culprit is not the computing, I think. It is actually a piece of sociology as to what led to developments in these areas. What is that piece of sociology? It's often been referred to as a common task framework. The common task framework is an idea. So for example, it's well embodied by MNIST, which is a huge data set of handwritten digits. It's well embodied by ImageNet, which is a huge data set of images to be labeled. What the common task framework said was, here's a canonical task. Is labeling images all of computer vision? No, but it seems like a really important subset, a tiny subset of computer vision. Here's a data set that we can all work on. Here's how people will share code. And then competition kicks in because people want to do better. So when you look at computer vision, it's a story much like this, where we were doing okay, but there were benchmarks and we did better. People did better and better and better on these benchmarks. If you look at something like LLMs, you'll see something like this. Here I found one where the x-axis is flops, but the y-axis is yet again another benchmark where we're doing better and better. The common task framework has been instrumental for the driving of the nature of the technology. I'm saying that because in a way it's kind of obvious. I'll actually give my last point. Audio signal processing. Until about 2020, this was an area where progress has been extremely slow. Actually, you should have noted how much less good there was, and that's because there was no common data set on audio signals. They just didn't have that. In 2020, it was like the stepchild. It was not moving very fast. So the common task framework is intriguing, and if you view everything through the lens of this invention, then if you go back to this and you said, why did we end up here? There's an easy answer. Every common task framework I know of, roughly, is an automation task. So why did we end up with algorithms that automate what people do? Because we set up a system so that technologists, computer scientists, developers competed on being able to automate people. So while the future looks like this, I think the future could just as easily look like bicycles for the mind. And the way we would do it is we would ask, what are the common task frameworks that have the same property that people could compete on? There's a single task. And that's an interesting question because it's easy to come up with automation common tasks. But augmentation common tasks, while they may take a little bit more effort, I think they are very doable. And that is, I think, the challenge for the field. It's a very practical challenge. We can name them, produce them, and put them out. And so I'll just conclude by saying, I think in 2025, we're engaging in the wrong exercise. We are presenting it as an exercise in prediction, but instead, I would argue it's not a prediction, but a choice. And the choice we have in front of us is, are we going to try to rebuild the bottom of the tech stack and try to get the kind of algorithms that maximize our capacity to augment human capacity? All right, thank you.
Great. Thank you very much, Sendhil. Okay, please take it away, John.
Okay.
Yeah.
Thank you. Great. So I'm going to talk a little bit about the part of that comes before anyone has a job, which is the matching aspect of the labor market and what this technology might mean for that. So this is what's distinguishing about labor economics in some sense is how hard matching is. These diagrams, the needle's actually huge, and so it really doesn't work. The truth is, the needles are actually very small, and sometimes it can be very hard to find that match. And kind of the reason, if we think about what's separate about labor markets, one, the number of potential jobs and potential workers is vast, right? And they're both differentiated on both sides. The rise of remote work probably makes this even harder than it was in the past. And people have complex preferences. Firms have complex preferences that are not so easy to express sometimes. Knowing if a match is going to be a good one can be a very difficult prediction problem. A lot of our colleagues right now are going to job talks and trying to figure out sort of who they should hire and is it going to work out. And this kind of takes time, and it makes it a challenging problem. So a natural question, if you have something that's an information processing task, can information technology help? And this is not a new idea. David wrote, I think, a really nice paper over 20 years ago that kind of tried to predict what would the rise of the internet and digitization do to labor markets. And he predicted a lot of things that did come to pass, but I think we might say that even 20 years in, it didn't sort of radically transform the matching process. Everyone tried to write papers looking at what did the internet do to the labor market, and you really just can't see too much. So that kind of raises a question. Is it something else? Was it just that the technology wasn't what exactly we needed? One point of view is that a lot of labor market problems are prediction problems, and these prediction problems are just challenging. They're difficult problems. And there's a great, he now has a book, but by a computer science professor at Princeton, talking about sort of AI snake oil, like when does this not work? And he kind of squarely puts predicting job performance as one of his snake oil remedies, that this is just kind of inherently hard. And I think that there's some good reasons to think like, hey, what are the chances that you can kind of predict how someone is going to do at a job in 30 seconds of looking at a video? Okay, so maybe that's a dead end, I don't know. But what about only the information processing and text generation aspects, right? There's a lot of things you have to do in a market, writing job posts, writing cover letters, interview materials. And these are the kind of things that these technologies are very good at. And we're starting to see a lot of stories about, a person used the technology to apply to 1,000 jobs, or firms using them to write job descriptions. I don't think you don't have to be too creative to imagine how this could kind of gum up the works in some things. And I want to talk about that in a minute. So just to emphasize, a lot of reading and writing goes into the matching process. But even if it's, say, individually rational for someone to use these tools, if we kind of take the whole market perspective, like what does that do? And I want to, we could imagine that that might make plausible but false claims, hallucinate requirements for jobs, You might get the case where everyone's using the similar algorithms and we get this kind of monoculture where everyone's sort of making the same judgments on people. And this third one here, part of what this can do is it can make things look like they took a lot of time, but didn't actually. And if you imagine that some part of the labor market matching is showing effort and that I'm really serious about this, it's not hard to imagine how this could kind of mess things up in some way. So I just want to talk about two papers that I've written with students of mine. One is happy and one is sad. That's why I have the two faces. One was with Emma and Sendhil. We looked at an intervention that took some job seekers about to enter an online labor market. Half of them got assistance with their resumes, and the other half did not get any algorithmic assistance. So you might be worried that this just sort of made people who were, here's the benefit. You can imagine that it cleans up typos, makes things clearer. But kind of the negative point is maybe it makes a person look better than they are, right? It could kind of muddy the signal. Well, am I out of time or is that just the phone? Okay. But what actually happened in the study, you actually had better workers. They ended up getting hired at a higher rate. There's not much evidence of crowd out. It seemed like it just removed information frictions, just kind of improved clarity. So that's the happy story. We wrote another paper that looked at the demand side. Well, let's give employers about to post jobs AI tools to help them write their job posts. This is a much less happy story. It was widely adopted. Lots of employers used it. They wrote a whole bunch more job posts. This ended up causing workers to apply to these additional job posts, costing them time, and it led to no net matches. And the net effect of this was to decrease welfare by a factor of 6 because it wasted so much time. The negative story here is essentially the employers weren't internalizing the cost this was having on the other side of the market because them wasting someone else's time is not their problem. So just one figure real quick. The mechanism that likely happened was that employers here, it looked like they were serious, but in fact they weren't. And what these two plots show in the treatment group, in the control group, this is the relationship between how much time someone spent writing a job post, which we can measure precisely, and sort of how long the post was. You can see a pretty strong relationship. In the treatment group, it's totally gone. They basically made employers that looked like they didn't have much effort, didn't put much effort, end up looking like everyone else. And this is what kind of threw workers for a loop. So let me just conclude. I think that there is promising thoughts here that you can use this for information processing and maybe generation, but it's definitely not something that purely just lowers costs and will clearly be good. It has a potential of mucking up this channel, and if you kind of think, what's the next step? If the open channel for how people match for jobs gets blocked, people will lean more on their networks and sort of who do they personally know and personal information. And I think it's not hard to imagine why that would not be necessarily a good thing. Okay, thank you.
Great. John, let me ask you a question before. Sure. So you have two examples here, and you found the opposite findings, right? One in one case it was really constructive. What is the distinguishing feature, and does it scale?
I think the first one helped convey information. It took away a lot of the improvements to the writing was this is the wrong way to word this, or this isn't very clear. So I think it injected more information. I think the second one ended up throwing information away. It made people look better than they were. So I think if I had to say, what should we be trying to maximize? It's are you generating truthful information, or are you not doing that?
And do you think if everyone started using the same thing to improve their resume, would it still be valuable, or is it only kind of positional?
I think to the extent, so crowd out is obviously first order concern in any intervention like this. I mean, I think if you really are helping people put their best foot forward, and then the firm still has to decide if this person is a good fit. But I think it really can surface. I don't think the number of jobs is fixed, right? And I think if you can highlight better matches, you can potentially increase the number of matches. So yeah, I think it's positive. But I mean, all this stuff crowd out is a first-order concern.
Great, thank you.
Well, thank you for having me. It's a pleasure to be here. So the broad topic of AI and opportunity is a huge question. And so I'm going to particularly focus on economic opportunity and draw on one very specific one of my papers and give you some granular insights that introduce two specific themes I think are worth thinking more about. So in particular, when thinking about the impacts of generative AI on the future of work, there are kind of three interesting questions. One is what happens to productivity, which workers benefit and why, and then what happens to basically all of the other aspects of being at work that are not about productivity. And in this paper, Generative AI at Work, which is joint with Eric Brynjolfsson and Danielle Lee, we provide some early evidence on these questions. And so we look at tech support, chat-based tech support, and workers employed by a large Fortune 500 software company. And they're basically answering questions about tax processing software. And the AI assistant we're studying here is giving suggestions to these workers about how to solve the tech support problems or how to speak to the customers. And this paper was started in 2021, so we're looking at a GPT-3-based assistant. And to study this, we take advantage of a natural experiment, which is the slow rollout of this tool across about 5,000 workers over the course of a year. Now, the first thing we look at is what happens to worker productivity. So the y-axis is the change in worker productivity, which here is resolutions per hour, number of tech support issues a worker is able to address per hour. And the x-axis is time relative to when the AI system is turned on. And you can see there's a fairly sharp, persistent increase, equivalent to about 15%. Now, on the graph on the right, I'm looking at how these increases are broken out by type of worker. So on the x-axis, I'm grouping workers by how productive they are before the AI system is turned on, with the lowest skill workers on the left and the top performers on the right. And you can see there's this fairly monotonic effect where the least skilled workers have the largest productivity gains. And we see very similar effects by worker tenure. Now, this is kind of hard to interpret, so let me visualize what this means for you. So this graph, I'm plotting this blue line is workers who never have access to the AI system. The y-axis is productivity, and the x-axis is number of months that the worker has spent on the job. And you can see there's kind of this positive relationship, what we call a learning curve. So over time, the worker learns how to do their job, they get better and more productive. Now, this red line is the same relationship for workers who are given access to the AI system in their first month. And you can see it's a much, much steeper line. The AI-enabled worker at 2 months of experience is as productive as a worker who never has access to the AI system after 9 months on the job. And kind of we see a similar effect with this green line where workers are given access to the AI at about 6 months. There still is this impact on what we call a learning curve. Now, the really key question here is, are the AI-enabled workers learning the same way those never treated workers are? So at call centers, managers are kind of responsible for teaching workers how to be good at this job. So what are questions that are commonly asked? How do you actually solve specific tech support issues? But managers are very much constrained in terms of their time and attention. They can't actually sit next to each worker and review at every question what is the right answer and what is the wrong answer, which is what the AI assistant is essentially doing. On the other hand, maybe the workers are just blindly copying these AI recommendations, so when you take away the AI system, they're actually doing worse or about the same as they would without it. And so to test for this, we look at periods when the AI system isn't generating suggestions just due to technical tech issues, so basically some software bug or some AWS outage. And what we find is that the AI-enabled workers continue to handle calls faster even when they don't have access to the AI suggestions, which is sort of exciting for two reasons. So one, teaching people to actually do things is a very costly, very time-intensive business, not something we've really been able to impact with technology thus far. And so it's potentially exciting that we have a system that is able to generate worker learning and build long-term skills. Now, kind of building on a point Sendhil made, this AI system was not designed to build worker skills. This is a completely unintended side effect. And this is not something the company actually was looking for when they were saying, which AI system do we implement? And so you can imagine there's potentially much larger learning gains you might be able to achieve if you actually designed an AI system that sort of balanced improving productivity and also improving worker learning. Now, in the paper, we also think more carefully about what exactly workers are learning. And there's one particular piece of being a call center worker that is very important. So one, speaking in comprehensible, or typing in comprehensible English, and sort of sounding like you're a native US-based worker. And the second is because US customers have a very, very strong preference for having tech support conversations with someone they think is based in the US. And in fact, one of the reasons so much of call center work happens in the Philippines is because the Philippines used to be a US-based colony. English is an official language of instruction, so they have lower wages and very high levels of English fluency. So kind of reflecting that, about 80% of the workers in our sample are based in the Philippines. And what we do is we measure the agent's text, what they're saying to customers in terms of, one, their grammatical correctness, and two, how native they sound using a couple of established language rubrics. And what we find is improvements with AI access among both these measures, but particularly for the Filipino workers. So in fact, it becomes much harder to tell, given the text of a transcript, whether you're speaking with a US-based worker or not. Now, you might think, well, this sounds like bad news for US workers, maybe there's gonna be more outsourcing, but kind of the twist here is this is actually something the Philippines are fairly worried about, because there are lots of countries with lower wages than the Philippines, and their advantage was the fact that they had this excellent English language fluency among their workers. And so just to highlight the second theme, because we have these very complex global nature of employment relationship, I think the sort of discussion of AI and opportunity would benefit from thinking about this in terms of a global lens. So, call center workers are not necessarily a good job in the US, but in the Philippines, they're a fairly high-skill, college-educated job. And sort of thinking about how all of these relationships shake out is particularly important. So with that, I will hand things over back to David.
Okay, terrific. Well, I mean, so here you have several really each of these presenters has given, kind of example and counterexample of how this can be done well and how, right, in Sendhil's case, it's bicycle for the mind versus, I don't know, the cyborg. In John's case, where we had, searching where it was adding noise versus adding signal. In Lindsey's case, we see kind of changing the competitive relationship between workers of different skill groups. So I guess the question is there anything we can take away from this in terms of a design? Our first panel was all about, what is worker voice? How do we shape this? If we had to say one thing we'd want to shape, knowing what we know here, what might it look like? So I'll put that question to each of you. Let me start with Lindsey, since she just spoke.
So I think the kind of impacts, as was discussed in the first panel, thinking about like how the AI system affects the experience of work beyond just productivity. Yeah. So in the paper that I just studied, basically being a call center worker, you have a lot of burnout because you're dealing with very angry people all the time. This AI system seems to kind of mitigate that because it basically helps workers, give workers suggestions on what to say and how to handle people who are very upset. You could also imagine in a case where there's an AI system that's handling the more routine tasks, the opposite is true. And so these workers are handling all the exceptions and the burnout is even more pervasive. And I think that is, harder to quantify, but something very first order in a lot of these jobs.
And let me say, since I've had the pleasure of reading this paper many times and teaching it, one of your very cool findings is that, it's a very high turnover job, right? It's kind of like a road rage phenomenon when someone gets on these chats, right? And you find that the turnover falls dramatically, I think dramatically. Junior workers tend to stay on longer. And so your interpretation of that is in some sense, either the computer does some of the emotional labor or it helps them to do the emotional labor, right?
I think probably both.
Yeah.
I think that, call centers, the average worker stays on the job for like 9 months or so. It's very, very high turnover. Part of it is that you're dealing with frustrated customers. You're working US hours, which tend to be midnight, overnight in the Philippines. The computer is basically helping you solve questions more effectively, so you get yelled at less, and then also with the emotional labor component.
Right. And none of this was designed to help workers, right? This was designed to help throughput.
That's correct.
Knowing what is now known about this, is there a way that is there something they were going to want to do better or differently, or is it is this the optimal? Is there more to do here, knowing what we've learned from this?
Yeah. So, I mean, I think thinking about so now the call center automation is moving more towards this. You have an AI handle the routine tasks, and the human workers handle the exception, help train the model, things like that. And that seems to be sort of the opposite of this story, where because that is the way the technology is moving, workers are going to burn out faster, effectively get a lower wage per sort of difficult task. And so you can imagine a system that maybe instead of handling the exceptions was a little bit closer to this co-pilot assistant, maybe being just as productive, but mitigating some of that burnout fear.
Yeah, I mean, I think that's what's very unusual in this case, right, is you could easily have imagined what they did is they throw the chatbot at the customer, and then if the customer gets sufficiently frustrated, they patch in a person. But that's not what they did. The chatbot doesn't talk to the customer. It talks to the worker who talks to the customer, right? So it's a distinctive case. I think it's super cool. I mean, we're at the AI. Our AI, stage AI research is basically like fables, right? Like, each of these cases is like the tortoise, if he went slower, he still wins the race kind of thing. We're all trying to take away these kind of meta lessons from very small examples, but this one is a very good fable. All right, so Sendhil, let me turn it over to you now. In terms of in terms of the design question, right? How do we shape the future? Who should we, you're advising an employer, you're advising the NSF. You're designing it yourself, you're advising engineers. What is the thing we should be trying to solve for, to use a Silicon Valley metaphor that I hate? What are the learnings, if I can double down on those annoying?
Double click.
I guess we first have to figure out what the mode is, and then I'm trying to also use your Silicon Valley speak. I think I'm still thinking about Lindsey, your question to Lindsey, actually, before I get to that, which is, if we knew this was the use case that we wanted, I'm not sure that we would have built the bot that we built. Like, if you just take that as a good example, if you think of just at its very core level, it's going to be making suggestions that have high probability of being the right thing to enter. Just take that as, assume it's a supervised learner, which I think roughly at some level it is. You say, given the customer query, I'm optimizing what answer might be the best answer to give, and I'm going to show that as a suggestion to the worker, and then we're going to do that. And that has some incidental learning benefits, because the worker says, oh, I hadn't thought of that as a good suggestion. But the learning benefits are incidental in that there's no attempt, for example, to do, here's the smallest change they could have done to that bot, which is they could have said, we're going to use that worker's history of chats, and we're going to identify the questions where their answer would have been very far from what we think of as the best answer. That's no longer saying what's the best answer. It's isolating the questions where we think there are teachable moments. Now, that's a small design change. It's not a big change in the tech, but it's actually quite a big change in the product, because now you're optimizing for the thing that's there. And so I think that principle is probably the principle that I think we could apply all the way from the NSF all the way out. I think in the actual building of these algorithms, I think because it's so, I guess what I would say is, it's so cheap and easy to take the thing off the tech stack that's easily available and do the minimal change to it, it just becomes easier and easier to do the simple automation thing. And at each stage, doing something slightly more complicated, like even the one we just described based on Lindsey's paper, is just a little bit more work. And from the point of view of the company, maybe that little bit more work is either hard or not cost efficient, whatever it is, but the social benefits could be quite high had we chosen that. And I think throughout the stack, I think that's been the divide. So if you're at the bottom of the tech stack and you're like, I want to build breakthrough innovations in language models, you're kind of, well, how do I show people I'm doing a good job? I do well on Big Bench. So now you're competing on the automation task. If there was another benchmark that was more about the back and forth between humans and shared understanding, well, now at the research level, you'd have some incentive. I just feel like we've slightly not aligned incentives all along the stack in a very tangible way that I do think we can fix without very big changes. And for me as a researcher, I think starting at the bottom would be very helpful, but I think throughout there's a lot that we can do that would be very interesting.
That's great. Let me say that again in a more pretentious and less transparent way. We had a job talk here last week by a guy named Bryce McLaughlin, and his paper was about, how should a computer advise a person, right? And basically almost all AI systems are not trying to advise the person. They're just trying, here's the best answer. But in fact, if they're collaborating, maybe you don't want to say, here's the best answer. You say, here's the information that would be most relevant to you making your decision. And so the best prediction might not be the actual prediction of what to do, but the relevant information for a decision maker. And I think the design goal of AI is let's replace the person. Then of course you would want to make the best prediction. If the design goal is let's complement the worker, you think about what is the best assist to the person, right? So when I think about autopilot, for example, right? The autopilot in my car, which is not a Tesla, not for political reasons, is it just nudges me to keep me in the lane. But I never have the illusion that it's driving the car for me. And maybe that's good, maybe it's bad. But I'm not gonna hand over control and stop paying attention. The danger of Tesla autopilot, right, is because it's trying to do the complete job for you. It's impossible for people to stay engaged in the decision-making process if they have no agency. Right? So there's a design problem there, and you can think of those as a tiny little example of this.
And if I were to add something to you, I love your advisor frame. If you think of the advisor frame, it's such a rich design space because the example you gave, let me give the piece of information that's most helpful is interesting. You could imagine saying, let me identify the weak point for you and tell you when that's happening. And one way I've come to think about it is to have true collaboration, you kind of need some implicit mental model that the algorithm is building of the person and some implicit mental model the person is building of the algorithm. And there needs to be some shared understanding. And in our current algorithmic architectures, our implicit mental models that algorithms have of us are terrible. Like they're just atrociously bad. And if you don't believe me, open up any recommender system you have. It's built by the biggest companies and ask, does this thing know me? I don't think any of us look at this and thinks, oh yeah, this algorithm really understands me. And so we haven't really cracked the nut of creating good implicit mental models in either direction. And I think that's one of the foundational things we need, yeah.
Perfect. John, so if reasoning from what you've seen, please go ahead.
I'm glad you mentioned recommender systems because I think they are terrible. And if you take in like the labor context, they don't know us. But you could imagine with the technology that we have now, you could build agents that would know us and could understand us and have a conversation. And specifically in the labor market matching context, if you go to the very highest end of the labor market, agents are everywhere, right? Sports, music, right? People have agents. They do a lot of this matching for you. Now with the capabilities that we have already, you can imagine sort of an agent for everyone, where you could take and tell it your true preferences, and it would go and sort of search on your behalf and even conduct interviews on your behalf. So I feel like this is a design space that's very, very open and bright. And so I think getting back to the papers I talked about, a core problem is a lot of, we have good mechanisms that economists, clever market designers have come up with, but the problem is they take so much time for the participants. Hey, give me your rank ordered preference over these 5,000 jobs. That's a little expensive for us. Agent time is asymptoting to free. So like we have this arbitrage opportunity between our time and their time that I think will let us do some creative things. Like, hey, go look at all 5,000 jobs in the Boston area and rank order them for me, and it costs a penny.
Great. Okay, so yeah, I'm going to open up a question. So let me just really emphasize, like, our former colleague Josh Cohen, philosopher, said famously, and I think is really the takeaway from this panel is, the future is not a prediction problem. The future is a design problem. And I think that's what you're hearing from all the folks here. Okay, so let me take some questions, starting with David Deming, and then the gentleman over here.
I have a question that is probably going to seem pedantic, so I apologize for that. But I kept thinking, Sendhil, about your bicycle of the mind metaphor, and also about some of the things John was saying, and Lindsey too. And I want to ask how literally you want us to take that metaphor, because you know, if you think about, like, let's say you and I ran a race, I don't know who would win. Maybe you would win if we ran a marathon.
I think I'd win it. We know that, David. Yeah.
I know I would lose if we...
Okay, so like you might win by 15 minutes, okay? But let's say if it's a marathon or something, but let's say we're riding a bike and you're in equally better shape, you might win by an hour because the bicycle is speeding you up, and so that's increasing inequality, even though the metaphors seem to imply that it's supposed to work with us, because it's a technology that levers your capabilities if we want to take the metaphor literally. And then if you take it even one step further, the question is, if you have a bicycle, you can go farther, where do you want to go? And so what's important there is, you have this bicycle, you can now go farther to different places, but the really important thing is, do you know how to choose the right way to go? And to some of John's comments about agents, it's like if everyone has an agent, well, it becomes then very important to make good decisions about how to use your agents. And there it's not clear to me whether it's inequality increasing or reducing, and what implications that has for opportunity. So that's why I say it's a pedantic question, but I think the metaphor is exactly right. It does seem like generative AI certainly is a bicycle for the mind, but it doesn't make me think it's obvious at all where it will go in terms of inequality and opportunity. So that's my question for the panel.
You want to take a minute? One of you can respond. Only one of you may respond.
I mean, I feel like one of the things that's been challenging to like wrap our hands around this is that it's not obvious what it does. Like, it makes childish mistakes in some domains and is like superhuman in another. And I think that makes it hard for us to reason like, oh, this is augmenting or this is displacing, because you have to get down to the granular details of like, well, what exactly are you talking about for this task, for this job? And I think that's partially why we struggle.
Can I add one quick thing,
great.
even though you said only one?
Yeah.
I think it's easy when we look in the world of automation to focus on inequality alone.
Yeah.
Because automation inherently is a transfer. One reason I like the bicycle metaphor is that, to me, those technologies, if done right, grow the pie a lot. And when we grow the pie a lot, we also should care about inequality, absolutely. But we also should be thinking, how much is the whole pie grown? And I think your point about those issues it's not that they get rid of it, but I just want to put both back in play in that case. And I do think what's exciting to me about these algorithms is the potential to radically grow the pie, that we should also be paying attention to that, as well as paying attention to the transfers, which are super important.
Yeah, 2 quick questions, thanks. So I guess following up on this bicycle of the minds idea, I'm thinking of an example where I think this is occurring, and it could be professional sports. If we think about like how much basketball or football have become sort of like chess, in the sense that there's so much pattern recognition, like all the thousands of coverages a quarterback will encounter preparing for a game, or NBA players have access to platforms and data analytics that can let them know how often they took a three-pointer from the corner or shot a left-handed layup with 20 seconds left in the game or something like that. So arguably this has raised the level of sports, made it much more cerebral, and even made it much more revenue generating. And I guess my question is, why isn't this the case in other forms of labor, that the players themselves have access to technology or the laborer has access to technology to become so much more imaginative or something like that? I'm curious what you all think about that, if that example holds. The other example I was thinking about was secondary school. So obviously with sort of Khan Academy or ChatGPT or even Kaplan, these programs, you could argue that a student who's just somewhat decent has the potential to become excellent and really compete with like top students who are academically stronger. But we also, I think, see students kind of reorienting and sort of have a lot of exposure to AI, but are sort of like, I'm not even going to compete at that level. So with my second question, I'm more interested in how you all think about concentration, differentials, and things like that, and if that is a factor in your analysis, or even something that AI is helping to contribute to, sort of like differential levels of concentration or something, you know?
Thank you. Does anyone want to take that question quickly? And then
I'll take the first one.
Okay,
actually.
great.
Yeah. The sports one is a great one because I think it illustrates 2 things, and both of them are implicit in your question. The first thing it illustrates is, it is astonishing that a quarterback can get such careful review of their past plays from the last game, but a judge and a doctor, who cares? It's just people and death and recidivism. Like, it is an astonishing asymmetry, and I think just closing that gap alone is important. And so that's key. So I 100% agree. The second point I'll make, though, is you already see the limits of why these technologies weren't really built for augmentation. So in sports, for example, what's been hard after the initial flurry, we should take more three-pointers, is the realization that, wait, like there's a bunch of stuff that's not well quantified. defense is not well quantified in the NBA. There's a bunch of stuff like that. And people now are struggling with, how do I match what the coach or the player sees with what's in the, how do we take what's not in the data with what's in the data and build tools to combine them? That's actually been the block we've hit. And so I think it illustrates both sides of it. Let's spread what we have, but we have new things to build.
Great. So, okay, I think I have a feeling we're short on time, so we're going to take a number of questions in rapid succession. So, let's see, this gentleman had his hand up, and then Frida Poli after that, and then Neil Thompson, and then all bets are off.
Okay, thank you for the insightful panel. So I wanted to put something we heard in the previous panel next to what we heard here. So in the previous panel, we heard that early career professionals are more likely to be displaced as a result of AI. And then here, we heard about the effect of AI on speeding up the onboarding of the early careers, which sound on surface as kind of like a good thing. But then there's a likelihood of kind of like a counter effect where if the onboarding process is kind of like more efficient and more costly for the firms, then the incentives of firms to invest in their early employees, that might actually go, that incentive might be affected in a way that the very employees might become more disposable in a way, like the job market, especially for the early careers, might become more modular in a way. So that might reinforce that concern that we heard in the previous panel. So I wanted to hear your thought about these kind of like different effects and how would you think the balance can be shifted.
Great, thank you. We're going to take a couple questions in a row. Why don't you take Frida, and then Neil, and then I'll ask more questions. But that's Frida, right there. Yes.
It's actually just a comment. So I think one of the challenges, as I mentioned on the previous panel, with the matching problem is that information is highly regulated. What you can ask a prospective applicant is highly regulated. And also, I think on the flip side, the firm is often remiss to disclose any negative information. So there's a much sparser information ecosystem, I think, in the problem, which I don't have a solution for, but I just wanted to make that comment. So
thank you.
So I wanted to push, Sendhil, you a little bit on your sort of framework, this idea that we were sort of moving towards replacement rather than augmentation as the way to do this. And I think one place we can see this is in science, right? Where, I mean, it's clear like the benchmarks are what everybody reports because they're easy to see and you can see progress and stuff. But, you know, there are thousands and thousands of examples across science of people using deep learning systems, replacing some other system tool that they had before. All of those cases seem very much like the bicycle for the mind kind of thing that you haven't. And then even in the cases where we see something like a large language model, so right now about 1 in 200 papers, scientific papers that are published, is using a foundation model for something. And I think in many of those cases, even though maybe for somebody in a customer service place, that's a replacement. For the scientists, it's often sort of augmenting what they can do by reviewing stuff. And so I don't have a good answer, but it'd be interesting to me to know how much of the benchmark phenomenon is sort of the hype of what people talk about versus actually the sort of net effect of all of the work that's being done.
So just to integrate these two questions, the question is, one is, does this make workers more, useful or more disposable because they're, they can be trained up so quickly? Another is really, what do you actually know and are constrained from doing? And a third is, aren't we already seeing actually a lot of this kind of augmentation? We just don't talk about it. So I open the floor to our three esteemed panelists.
I can take the last question. So I think one key difference is who's making the adoption choice. So in the question of scientific papers, it's often the person who's like, oh, it would be very cool if I use this model to do X. And of course, they're not going to choose to use a technology that's going to automate them away in some fashion. And I think that's very different than in the business case, where a lot of companies their metrics are productivity or efficiency. And they're interested in this new technology. It's very confusing. They aren't necessarily thinking through all of these issues the same way we are. And so the choice of an automation where you can very clearly quantify the cost and the benefit is more straightforward than something where you're like, oh, we'll augment people and hopefully something will improve over time. And so I think who's making the adoption choice matters quite a bit.
I think I'll add, the science piece is fascinating because I think it helps you totally see that there is augmentation, but it's augmentation despite design So let me give an example. Take protein folding. Do we understand something at a fundamental level about biology better because we have a better protein folding algorithm? Now, that issue is not a nebbish issue, or not, it's not I'm not nitpicking, being pedantic, as David says. I'm pointing out that these tools, they're good for certain things, but science involves a cycle of solve problem, understand, improve, understand, solution. And in a bunch of these things, it's a well-known technical blocker that if you built a foundation model, if you built whatever, the lack of interpretability has left us. Not that people aren't working on it, they're working on it, but it is far slower going. We've not had nearly as much progress on the interpretability piece on other pieces. And so I think even there where you see human, like at a production level augmentation, I think we see that it doesn't have that takeoff component. And you can see it from the protein. It's not like there's been some big discovery about biology.
Julia, do we have time for another cohort of questions? All right, awesome. Okay, oh, great, okay. Molly, did you have your hand up earlier? No, okay. Who else has questions? This gentleman over here, and how about and this person, gentleman here, and then someone from this side of the room. This room's, I mean, you guys.
They don't like us.
Siberia of...
Okay. Did someone get a microphone?
Over there.
Okay, go ahead, sir, please.
Thank you. Can you hear me?
Yes.
So I'm Daniel Jackson from Computer Science. So a question for Sendhil. I really enjoyed your analysis of the Common Task Framework, but I wonder, putting it provocatively, if the problem was not the Common Task Framework, but the very idea of quantitative measurement. One of the things I think is a kind of a paradox of computer science is that if we look at hardware, we can certainly measure performance in memory size and processor speed in quantitative terms. But the greatest advances in computing have arguably been things like the WIMP interface, just invented at Xerox PARC, and modularity mechanisms in programming. And not only were those not driven by quantitative measures, but I don't believe there have been even ex post facto any successful attempts to measure their significance. And so my question in short is, how do you work in a field where it could be that in order to pursue design effectively, you actually have to completely decouple your assessment of design as you're doing it from ex post facto assessments economically later?
Great. I'm gonna actually take a few questions. Just the next person who had his hand up was this gentleman here. Yes.
Hi. So I want to ask a bit more specifically about incentives of the augmenting versus automating part. You mentioned, Stefanos Tiros, Harvard Business School, I forgot. So you mentioned, I think you were mentioning kind of together the example of, let's say, giving you the answer versus giving you the relevant information to make the decision. And I can think of a specific example, let's say in the medical sector, right? You can think of AI tools in the end being a tool that the doctor uses to not have to bother to automatically get some kind of answer for the patients, which might take a bit longer to create, and it would be about automating, in essence, the process, or it could be about giving the ability to give the relevant information to specialized nurses for them to make these kind of decisions. And my question there is, because you essentially talked about these things, but what would be the specific incentives, whether they're institutional, whether they're taxes, what are the specific incentives that you think can make or break the switch to one or the other? Because to me right now it's not clear which way the technology would be heading at.
Great. Okay, let's take one more question, and then we'll come up with a bunch of answers.
Thanks very much for all of those thought-provoking talks. And so Sendhil and John, you each sort of identified, I think, what I also believe to be very important problems. In the case of John, the fact that the information could be obfuscating rather than really increasing information, and Sendhil's case, the fact that, these are not designed or are not currently very effective in working with human decision makers. So what is in my mind is like, do you think this is like a hard limit given the current architecture and the things to come, or are these sort of rough edges along the path that are going to be smoothed out? So are these things going to affect us in 10 years' time in getting productivity and human complementarity, or they're just going to be solved on the way?
Okay, great. So we have 3 questions really about design, measurement, and how do we break out of the measurement framework, about what are the incentives, and then kind of where does this lead. So take it away, you guys.
Well, I can go. So, to Daron's question, I do think that we had a whole bunch of things in the world that kind of depended on writing being an ordeal. Like you had to prove something through writing, and that signal kind of got replaced almost overnight. And I think we just haven't worked out new mechanisms. Like we're kind of in an early stage. So I'm confident that people will figure things out, but with the one exception that there's no guarantee in a labor market at all that all the externalities get internalized. So this may be a particularly hard problem. You might imagine that platforms would do a lot, but I think that ends up having its own problems. So I'm cautiously optimistic, but I can see some issues, and I can tell a story of why this wouldn't get fixed very easily.
I think I'd give an answer. I think I'd link Daniel's question and yours question, Daron, into one point, which is that I 100% agree with you. I think if you look at the supervised learning frameworks that we've had, I think one way to understand a lot of the AI applications that have gone awry is that it is a failure of quantification, or said differently, it's about what was not in the quantified bit. It was sort of either you optimized for labels that missed something, you missed some inputs, so it is exactly about the qualitative that is not in the particular quantitative, and I appreciate why you might very well be right that we should stop chasing metrics, or we may end up in a world where we have some proxy metrics that we just constantly keep changing. I don't know, and I think that's an issue. But to your point, Daron, I think that this is a little bit like seeing like a state. I'm both optimistic and pessimistic. I think if we act now, I think we have a chance to get to an optimistic outcome. But this thing is on a roller coaster on its own. Like, it's got tracks, and it's heading this way. And the more you take the metrics very seriously and you've optimized for them and you've kind of done this, they create their own reality. It's like people just forget. This is not like, people are like, oh, well, I'll give you my favorite example of this. People are like, oh, well, this can read as much as as well as a radiologist. But yeah, on 10 of the 25 things a radiologist does. What about the other 15? What about the fact that the radiologist gets some intuition about what's happening, and then they actually need to talk to the doctor? There's a lot of qualitative stuff that happens in every one of these systems, and if you narrow the task to be on the quantitative, and you slowly forget the qualitative, and things can end up looking like you're doing well, but it's kind of an illusion. So I don't know if that's a wishy-washy answer.
So I'm going to take the liberty of just sort of building on that point. The way a lot of medical technologies are tested is they're tested against data sets, right? You have benchmark, how did the doctors do on this data set? How does the machine, but doctors data sets don't walk into doctors' offices. That's not how they interact with them. And a data set does not create itself either. A data set is actually the end result of lots of medical decisions along the way about what test to order, because you just don't do an exhaustive set of tests. So it's just not the right comparison to ask, how does this machine do against a data set versus a doctor? The right comparison is, how does the doctor do with and without this tool, and what would allow the doctor to be more effective with that tool, recognizing that there will still be a doctor. And this is, I had this conversation, last week with, one of the founders of DeepMind, who was convinced that we're going to have AGI, in the very short run. And I said, look, I grant you we'll have AGI tomorrow morning. You've solved it. We're still going to have nurses 25 years from now. So let's talk about how we give them better tools. That was not universally agreed among the two of us, but okay. I think I'm just gonna. Since we're out of time, I'm just gonna say, I think, despite all the anxiety we have, you have to believe that there's incredible potential here, right? That the potential to advance the field of science, to solve some of the most challenging problems we have, whether it's in climate change, whether it's in medicine, whether it's making healthcare more available, whether it's allowing people in the rest of the world who are not English speakers to, compete in a substantially English-speaking or Chinese-speaking economic domain, and to, bring tools to where tools were unaffordable or unavailable or inaccessible. There's got to be great potential here. So we should again be thinking about, how do we design? How do we, instead of predicting, how do we design appropriately? And I think I take much inspiration from what we've heard here today. So thank you very much to our 3 panelists.